Okay, thank you. Thank you for this opportunity to do this communication session with you about how to build some of the technical topic about the data center related about the artificial intelligence and high performance computing. And 30 years before I graduated from the university, actually my major is atmospheric science, not computer science. Yeah, so during that time, I spent a lot of time to do the computational model for example, during that time still the MM5 or something. Yeah, I still remember that. Now it's Worf, yeah, by Anka. So now I work for Huawei as a CTO for the enterprise business. So today I will talk a little bit about something about the high performance computing development and challenge, small part, and then about the synergy of the computing, storage, networking to help you to build the infrastructure level to support, to do the I/O computing acceleration for the HPC and also for AI. The third part, I will talk a little bit about some of the very new topic about how to build the new scale-up infrastructure, and also the flexible topology of such things. The fourth part about the management. Okay. So during the past several years, so for the computing part, we evolved to support from the general purpose computing, for example, like the transaction, for database transaction, big data, such part. All these parts are focused on the I/O for the I/O pattern view. Normally it's focused on the IOPS for the random I/O or such things. But for high performance computing and artificial intelligence. So during the past several years, so for the computing part, we evolved to support from the general purpose computing, for example, like the transaction, for database transaction, big data, such part. All these parts are focused on the I/O for the I/O pattern view. Normally it's focused on the IOPS for the random I/O or such things. But for high performance computing and artificial intelligence, that's totally different. So for artificial intelligence, it's computing centric. So GPU, we all know that GPU is, especially for the artificial intelligence, we need a lot of computing power to do the matrix multiplication. So, like, for example, like the dot product of the vector. So for this part, we use a lot of computing power. We need to use sometimes we will face, normally we will face the communication war or the memory war. So we need to solve this communication memory problem to accelerate the computation. So also the I/O pattern of the HPC and AI is different. Throughput, we need to focus on throughput, high bandwidth, low latency, or such things. So for high performance computing, there are multiple layers, very complex. So from the infrastructure level to hardware level, layer 2, I call it, or the foundation software. For example, like the job scheduling, like the Slurm for high performance computing part. So there are a lot of things their synergy to pursue the much larger cluster size, cluster scale, energy efficiency, and also the higher utilization. So for this part, how to boost the cluster utilization is the major challenge we need to face. For AI, during the past several years, we all know that we face the challenge of the large language model. So I remember that's the 2020 when the GPT-3 was announced. We all be aware that we are just at the beginning. During that year, we are at the beginning of the artificial intelligence. So after that year, the whole AI evolved very, very quickly. So for AI, what we face is yesterday, we talk about the scaling law, right? So for scaling law means huge data, trillions of the token to do the training. But we have to use a lot of computing power. For example, to train the foundation model, we need at least 10,000 GPU or MPU to do the training. For example, for the Llama 3. In Llama 3, Meta uses about 16,000 GPU to do the training. So it's a huge cluster to do the training. And even for inference, we need a lot of GPU to do the inference. Since the context size is long, and also we use a lot of token to do that. So even another thing happened during the past 2 years is DeepSeek, right? DeepSeek use a model of the MOE, mixture of expert. That save a lot of computing, the memory. Do not activate so many parameter as before, but still use a lot of computing power. So for the AI part, our challenge is about the size. We still also need to care about the computing units. So for the distributed computing environment, even we cut the model based on, for example, the tensor, parallelism, and expert parallelism, and also for the pipeline PP and DP data parallelism. So still we need a very large cluster, and also we need to solve the issue for the communication inside the cluster and also outside the cluster for scale out. So that's the major challenge we focus. So the method, when we talk about the computing power of the cluster, computing power, here is we need to first the number we can have is a single chip computing power with the cluster size multiplied with the cluster size, and then computing efficiency and availability. So we need to boost the computing efficiency, availability, and cluster scalability, 3 aspects. For networking part, RDMA, Rocky is a common sense for us to help us to access the data very quickly. So that's and also for scalability. Yesterday, I remember for the LPS, for the supercomputing cluster, you use the Dragonfly topology, right? So yes, Dragonfly is an option, and Cloud is another option. Then later today in the section 3, we will talk another advanced technology we provide to give you another choice. And for storage, yes, for a lot of batch data, and also for data loading, and also for the checkpoints, and also to support the cache, KV cache, for the inference part. So for this part, we need high performance storage, and also heterogeneous computing. There are CPU, GPU, and the ratio of the CPU to GPU is different in HPC and AI environment. For example, in AI environment, CPU is just used to do the management schedule. GPU will have the compute to do the work, 99% of the work. But for the high-performance computing, it's different. For example, in the weather model, normally it's focused on, it's CPU-centric. Nowadays, yes, we can use, for example, the GPU to do the data assimilation or to do the physical process, parameterization or such things. But the ratio of the GPU is still low in the high-performance computing part. So, but yes, maybe you will talk about AIFS. Yeah, AIFS is a different story. It's totally data-driven. Yeah, it's not related to the dynamics. So for networking part, I just talk about the efficiency of the exchange of the network. So how to make full use of the links in the class or even in the Dragonfly architecture. How to make full use of the multiple links is a challenge. So Huawei, we provide a technology, we call it the NSLB. NSLB is the load balance service. But we know that for the networking part, normally the load balance is determined by the local. But for NSOB, there is by the global. It has a global view for the load balance. That means it's topology aware. So so there are several versions, NSOB-static and control plan, and NSOB-data plan. Yes, we have several versions to help you to achieve the much better load balance. And also for the expansion and for scalability, provide the more networking capability ports to support larger cluster. For storage part, when we talk about the AI for the storage, we know that there are several stages. The first stage is to get the data, prefetch the data. After you have do the quality control of the data, you need to prefetch the data into the cluster. And using the cluster to load the data to do the training, to do the forward propagation and the back propagation, and then update the weight and BIOS or such things, right? And then to do the checkpoint. And to do a checkpoint, if there is failure, you need to restore from the checkpoint. So in each phase, there is different kind of requirement, technical requirement for the storage. So, but one thing we need to remember, the synergy between the storage and computing is very important. For example, when you want to do the checkpoint, when the GPU must be idle to wait for the checkpoint to be finished. That means if we develop a mechanism for the checkpoint to be asynchronous, then the GPU will not be idle. So for this part, it's a huge, very, very advanced feature, but there must be the synergy between the computing and storage part. And yes, this slide is the advertisement. Yes, we have developed a lot of the portfolio for the storage part can help you to provide the data plan, control plan separation to boost the performance and also to provide the persistent KV cache. Why I mention this? So when you install the machine to do the inference, for example, for the transformer, you need to calculate the K and V many times. So that's duplicate work. If we have the KV cache, we provide the KV cache persistent for you to accelerate the inference. Okay, DeepSeek is a very, very hot topic. DeepSeek announced the version 3. Version 3 is a foundation model, just like the Llama, just like Llama 3 or Llama 4. It's a foundation model. But based on DeepSeek version 3, they use reinforcement learning to train another model, R1. R1 is the model which can help you to build the chain of thought, to do very strong capability to do the inference. So based on R1, you can use distillation to enable the model of other model, for example, like the Llama, and to use it to enable the Qwin other AI model. So Huawei, we provide the all-in-one box to help you to install the DeepSeek very easily. There are management software, storage, networking, computing, GPU, all included and inside the one box to help you to build a very simple environment. And the third part is the advanced part. So when we talk about the computing, there are a lot of components: GPU, SSD, memory, HBM, memory, general memory, and HBM, and also the CPU, and also others like the TPU. So there are many connections between them. Inside the box, normally it's PCIe or CXL to do the extension, right? And outside the box, between GPU, NVLink, and also such technology by NVIDIA, right? And also RDMA, Ethernet, Rocky for the scale out to communicate across the superpole. So there are so many protocols, and also for them, there is conversion of the protocol. So for Huawei, we propose a very latest technology. We call it the unified bus. Unified bus is the latest networking technology we provide to help you to build a unified link to connect the GPU, CPU, memory, and also the outside extension device together. That means, based on this architecture, the protocol is very simple. It's very simple and powerful to provide a high performance and low latency. And also, it's based on the memory semantic. So it can use, for example, the get, put, and then to copy, restore, such things. Know that very easily. That it's not the message based, so that it's transaction based. It can be aware of the transaction, and also, so unified bus is what we propose to help you to build a scale up, both scale up and scale out in a unified architecture. And then, based on unified bus, we already announced this technical paper, about how to build a large scale network to support artificial intelligence. So we call the UB, Unified Bus Mesh, or n-dimensional full mesh network, to help you to form. It looks a little complex, but actually not so complex. That means inside the UB network, we can help you to build a much larger scale-up network. And also, it's provide hierarchical bandwidth allocation. And one advanced feature here is all-pass routing. It's a dynamic routing. So if you are familiar with the routing, normally we would use the SPF, shortest path first. So for SPF, the router or the switch will choose a single link with the lowest cost to transfer data. So even there are, but for AI, the difference is AI is eager, is hungered for the bandwidth. We need to utilize the paths as many as possible to boost the utilization ratio. So we provide the APR, all path routing. It's based on source routing and high availability features. So what's the function? The function is, after we install the UB, we turn the architecture to the CPU-centric, to the symmetric architecture. That means outside the bus, everything symmetric, can communicate quickly. And another innovation, maybe you have already know that, since I remember Google have already deployed this. It's about, we call it the optical exchange connection. That means when you build AI data center, yes, for the networking layer, it's based on IP, there is flexibility, right? But for the physical layer, for the optical layer, no flexibility. After you install it, it's fixed. We provide you a very powerful architecture. We call it OXC, to help you to do the software-defined optical network. That means to make the optical layer to be flexible. So if you want to use the optical to build various kinds of topology, point-to-point and cloud or such things, this can definitely help you inside data center, provide a very definable topology of the optical network. So that's two very latest technology. So for the OXC and also for the unified bus, help us to build a all-in-one and symmetric physical layer. But above that, scheduling and data and resource allocation, flexible allocation is strong request for you to allocate based on the request of the HPC or AI, the model. So the software is very important. So we provide the software. This software still already can be used on the Huawei public cloud. But for the private cloud, maybe we still need some time to migrate it down from the public cloud to the private cloud. So this software, we call it Cloud Matrix. It's an architecture. Cloud Matrix can help you to allocate resource very easily. That here. So for the physical level, we have already support by the Unified Bus. So it's software level to help you to do the scheduling flexibly. That's what we achieve. So Cloud Matrix can be very good for the AI scenario to boost for example, for the all-to-all communication, for the collective communication library, it can improve about 10 times efficiency. And for the fluid computing environment, 50 times higher than before. So, okay. So that's all.
Okay.
Thank you.
Thank you, Marcel. Our next presentation comes from Giordano Mancini.